killing. Right, well, hang on. Hey, I just want to take a look at a couple things here. Let's see here. Okay, first thing. Tonight, 9 o'clock, I'm going to just jump on Canvas conference. If anybody has questions over, anything you want to go over, that's fine. If you do, it's not like a review. I'm not doing anything. You're asking me questions. So if you don't have any questions, you don't need to show up. So do that tonight at 9. I'll also do it tomorrow night, but I don't know what time it will be tomorrow night. Depends on when the volleyball game gets done. So I will just let you know through Remind. But I'd say around 9:30ish, around there. If you want to, like, if you're working through things and you got a question, you want to hop on, that's fine. So be on through probably around then. All right. Here's 26, and I want to take a quick look at 29. Maggie, you got the equations for 29.
F of x equals 3x plus 1.
Hold on. Okay, and g of x.
X minus 1 over 3.
Okay, I just went and going through the homeworks. I checked most of them that had been previously turned in. For the most part, okay, just a couple things here or there. So for 29, if we're looking at f of g of x, and we're asked to show their inverses. So if they are inverses, what does f of g of x have to equal? It's got to equal x. So when so you know what you're looking for, we got to see, well, does it really work out? So it's going to be 3, and then in x, we put in x minus 1 over 3 plus 1. Two ways you can look at that. One is, what can we do with this 3 and this 3? They can cancel. Those can cancel. And that's absolutely legal. That's fine. When you cancel those, you are left with this x minus 1 and that plus 1. And so that's just x. Perfectly fine. Some people want to distribute this 3. Perfectly fine, but to distribute it correctly, make sure you just distribute it to the numerator. So it becomes 3x minus 3 over 3. Do not distribute it to the denominator and make that a 9, because this is really 3 over 1. Okay, and the 1 would be what you distribute. And now, different ways you can look at this, but this is 3x over 3 minus 3 over 3 plus 1. You can just split those apart, and then that cancels, and you're left with x minus 1 plus 1. However you get there, you're still going to get x. Okay, so just be careful on that distributing if you do choose to do that. And now, what is g of f of x? Let's take a look at that. G of f of x, that is going to be, all right, that x comes out. You get 3x plus 1. This minus 1 is still in that numerator all over 3. We'll simplify the numerator. Plus 1 minus 1 is 0. You just get 3x over 3. Just get x. Okay, for this. All right. Anything else homework-wise on there? Okay, 38. That's just a picture. You just got to flip those. Made a couple comments on a few of yours. You just got to be careful there when you're doing that one. Questions? Okay. Finish up the guided notes from Friday. Still dealing with inverse functions. All right, we're on that front of that page, number 2. We did number 1. This should be number 2, where we're verifying and following their inverses. There. Yeah. And gosh. Getting straightened out. Yep. Okay. All right. Cool. Okay, so f of x equals x plus 1 over x minus 2. G of x equals 2x plus 1 over x minus 1. All right, to save a little bit of time, we're not going to do both directions. I'm not going to do f of g of x and g of f of x. We're just going to do one of them. Okay. Now, if there are inverses, f of g of x has to equal what? F of g of x has to equal what? Has to simplify to x. Has to simplify to x. We know what we're doing, and okay, we got to get that. So let's do that. We're going to show f of g of x equals x. So let's see. So f of g of x equals, and so I take that, we're replacing in for these x's with this whole expression. So it becomes 2x plus 1 over x minus 1 plus 1. And then that x is 2x plus 1 over x minus 1 minus 2. All right, you cannot just do this. You cannot say equals x and then move on. No. Obviously, it has to equal x. No, you got to do a little bit of work. All right, but how are we going to do this? How are we going to show it? We got two options. You can get a common denominator in the top, or we can multiply to get rid of fractions. Tony, well, we'll let you drive the bus today. How are we going to do this?
Well, wouldn't you multiply the -2 by x minus 1?
Just that one?
Or did you do both of them?
You got it. I think this is what you're telling me to do. Multiply the top and bottom by x minus 1?
Yeah.
Yeah. That's it. That's the ticket. Yes. All right, we'll do that. We'll do that. So you're going to distribute the x minus 1 to both of them? All right, that's fine. That's fine. What happens when we multiply x minus 1 times that first one? The x minus 1s do what? They cancel. And so we are left with 2x plus 1. And then x minus 1 times the 1 gives me plus x minus 1 over x minus 1 times the first fraction. The x minus 1's cancel. You're left with 2x plus 1 minus 2 times the quantity x minus 1. Distribute, simplify, really nothing to distribute the top. But I'm just going to drop the parentheses. I get 2x plus 1 plus x minus 1. And in the denominator, I got 2x plus 1 minus 2x plus 2. Well, numerator gives me 3x. Denominator equals 2x minus 2x is 0. So I'm just left with what? The denominator. Just left with 3. Okay. And then 3x divided by 3 is x. Okay. And so we're done. We're done. Should I do the common denominator way as well? Anybody need to see? Would like to see that? Speak up. You're loud. No. Okay. All right. And now you can g of f of x. Like I said, I've never come across a case where f of g of x equals x and g of f of x didn't. Technically, you need to show that though, because it is different work. But we'll just stop with that. So therefore, those two are inverses. Okay, those two are inverses. All right, making sure we know what that means. So f of g of 8. Adam Lippy, what would that have to equal? 8. Has to equal 8. Whatever you plug in, when you got inverses, you do the composition. You got to end up back with that same thing. So if I would plug in 8, it's probably not going to be nice, is it? No, so we're not going to mess with it. We're just going to say it's 8. All right, now we're going the opposite. Well, I say the opposite. I've given you two functions. I said, are they inverses? And you showed me they are. Now I'm going to say, all right, here's a function. What's its inverse? Okay, so I'm giving you the function. You have to give me the inverse. And then a big part of this is the domain and range. Okay. First thing you want to do, take out the f of x. Put in a y. Okay. Second thing you do, everywhere there's an x, you make it a y. Everywhere there's a y, you make it an x. So you flip all your x's and y's. Okay. So to find the inverse, switch all X's and Y's. Okay, and solve for Y. So I'm going to make this an X. I'm going to make the X a Y, and then I'm going to solve for Y. And I'm going to add 12. I'm going to add 12. I get X plus 12 equals 3Y. Divide everything by 3. Divide everything by 3. And that gives me Y equals 1/3 X plus 4. 1/3 X. Now, so F of X equals 3X minus 12. Now I can rewrite this as the inverse. So F inverse, what I say is 1/3 X plus 4. 1/3 X plus 4. All right, let's see what happens. So what is F of 8? Plug in 8. What do I get? Tyler, what do I get when I plug in 8?
Which one? F of X or F of X?
F of 8. So then F of X.
12.
So I get 12. 3 times 8 is 24. 24 minus 12 is 12. So what's F inverse of 12? What's that going to equal? F inverse of 12, 1/3 of 12 is 4. 4 plus 4 is 8. So that makes me feel confident that's right. Because remember, that would be F inverse of F of 8 has to equal 8. So you have to come back with the same. All right, what's your domain and ranges? What's your domain and ranges? Okay. Before that, do we have any? Are we dividing anything in the denominator? Nope. Do we have any square roots? Nope. So domain and ranges, or domain for the both function are all real numbers. Okay. So domain of F negative infinity to infinity. Domain of the inverse negative infinity to infinity. All right, so if you look up above, though, now you can probably figure out the range. This isn't too bad, but for others, it's not as obvious. For number 4 up above, it says the range of F of X is the same as what? The range of F of X is the same as the domain of the inverse. If I know the domain of the inverse, I know the range of F, and it is also negative infinity to infinity. And then the same thing. The range of the inverse is the same as the domain of the function. So that is negative infinity to infinity. All right, I think we're on the back. Those were 2 linear functions, and linear function, its inverse will also be linear. Okay, let's take a look at something that's not linear, that won't have all real numbers for its domain and range. So I'm going to rewrite this as y equals 2 over x plus 5. Switch out every x with a y and every y with an x. And so this becomes x equals 2 over y plus 5. All right, we did this in the first chapter because this is important in this area. How do you solve this for y? Okay, we got a y in the denominator. We got to make sure, we got to get rid of that. How do I solve this for y? Nathan?
Multiply by y to all 3 of the terms.
Yes, multiply all 3 terms. So x equals 2 over y plus 5. Multiply all 3 terms by y. All right, I don't want to assume anything. What's that going to give me, Luke?
XY equals 2 plus 5y.
All right, where do I go from there? Where do I go from there? We got to get y by itself. Nathan?
We can put the xy and the 5y on the same side, then take out common denominator. Or yeah, just take out y.
Take a y out. GCF.
Yeah, that's what.
I knew what you meant. All right, yes, you have two terms with a y in it. You cannot just divide by x, like say, oh yeah, I'll just divide by x. Nope, you get that y there. We got to get both on the same side. Okay, get both on the same side. So I get x, y minus 5y equals 2. Factor out, GCF, factor out a y. And then I'm going to divide by that x minus 5. X minus 5, x minus 5. So I get y equals 2 divided by x minus 5. All right, so there's your inverse. You can plug in a couple of numbers if you want to test it to make sure to do that. But we got f of x. F of x equals 2 over x plus 5. And I got the inverse to be, what was that? 2 over x minus 5? 2 over x minus 5. All right, don't worry about the ranges yet. Worry about the domains first. Figure out the domain of each of them. What's the domain of f? What's the domain of the inverse? So I'm going to have, and I'm just going to list them all here for a second. So the domain of f of x, the range of f of x, the domain of the inverse, and then the range of the inverse. All right, just be careful of that first one. 2 over x plus 5. Okay, you got that plus 5 separately, but you still can't divide by 0. So what can x equal for the first one? It can't equal 0. Okay, so it's everything but 0. So the domain of f of x is negative infinity to 0, union 0 to infinity. All right, that second one. Okay, that second one. Emily, what's our domain going to be for f inverse of x?
Negative infinity to 5, union 5 to infinity.
Negative infinity to 5, union 5 to infinity, because we cannot include 5. Okay, now, you got the domain of the function. The domain of the function has to be the same as what? Okay, that's up there on number 4. Or wait, actually, it's on the other page. But it's on number 4. Josh Martin, I think you weren't here, but the domain of the function has to be equal to the
range of the inverse.
The range of the inverse. Okay, those are going to be the same. So you don't have to physically figure out the range. You just know the domain of the function, and now that's going to be negative infinity to 0, union 0 to infinity. And then the range, the domain of the inverse is going to be the same as the range of the original function. So that is going to be negative infinity to 5, union 5 to infinity. Okay? So those are always going to be the same. Do the domains, use the domains, get your ranges. Okay? For that. All right, another one dealing with finding the inverse. All right. These are a little bit more involved with the algebra, okay, than that first one. So take a look at this one. F of x equals 2x over x minus 1. We're going to find the inverse. Then we're going to find the domain and range. So take out the f of x, make it y. Okay, flip everything. So everywhere there's a y, make it an x. Everywhere there's an x, make it a y. Solve for y. Okay, solve for y. All right, you got 2 y's, but we want to get rid of that fraction. Let's see, what do you think we're going to do first here?
Multiply by y minus 1.
Good. Multiply both sides by y minus 1. Y minus 1. So I get x times y minus 1 equals 2y. Y minus 1's cancel. All right, where am I going from here, Cooper?
I think I actually scrubbed it because I have a good way, but that is okay. Oh, hold on. My apologies.
What'd you do?
Oh, yeah, I did that. Yep.
Okay.
And then I multiplied in. Got it. X times y minus 1. So
Distribute?
yes.
Distribute.
Yeah, not coming to my mind today.
It's all right.
So it ended up being xy minus x equals 2y, and then I moved the x over to the other side, and I subtracted the 2y over to the xy side.
Okay. Ooh. Good point. Clone. You got two options here, and either one is fine. Your answer will look a little different, doesn't matter. But Cooper said, let's move the x over and move the 2y. You gotta get the y's on the same side. Okay, let's do that. So he added x here. I'm just gonna put it over here, minus 2y minus 2. I'm just doing two things at once. It gives me xy minus 2y equals x. Factor out the y. Factor out the y. And you get x minus 2 equals x. Divide by that, you get y equals x over x minus 2. Okay, good. What's your other option? So that's why I cloned it over there to the right. Instead of moving the x and moving the 2y, what could I move right away? I could just subtract xy. So you could do this, and I get negative x equals 2y minus xy. Factor out your y, and then divide by 2 minus x, divide by 2 minus x. Let me just reverse the order, put y equals negative x over 2 minus x. Both are fine. Okay, absolutely fine, but don't say, oh, I didn't get it right because I didn't match your answer or whatever. How do you know that they're equivalent? Everything is the opposite in terms of its sign. So that's an x, that's a negative x. Well, x minus 2 is the same as 2 minus x because we're making this negative, we're making that one positive. Just reordered it. So no, if you've got either answer, they're absolutely fine. Okay. All right, now domain and range. Let's go f of x equals 2x over x minus 1. F inverse of x equals, what was that? I'm going to go with the x over x minus 2. And whoops. I'm just going to shift that down a little bit. All right, go ahead and list the domain and range. I'm going to pass out a review sheet while you're doing that, so that you have this. And if you're not sure what the domain and range is, then just be patient.
Is this making sense?
Ready? All right, when's the tournament?
Yeah. I'm not a resource.
Oh,
How do they play? I'm not sure. You're not letting me go to the same
You good? Saturday.
All right, domain,
I don't believe.
f of x, range of f of x, domain of the inverse, range of the inverse. Domain of f of x. Grace, Bill Home, what do you think?
Of f of x, I got negative infinity to 1, union 1 to infinity.
Good, because we're going to throw out the 1. 1 minus 1 would give me 0. And Jacob, we missed you. How about domain of the inverse?
I got that as negative infinity to 5, union 5 to infinity.
Is that supposed to be x minus 5 or x minus 2?
Sorry, that was I did the wrong problem.
Alright.
Negative infinity to 2.
Good. Union. Okay, and so the domain of the function is going to be the same as the range of the inverse, and then the range of the original function will be the same as the domain of the inverse. Okay, good. Now, I did give you a review sheet. I do need I need to add page 303. We didn't get to those on Friday. You need to practice those because you're going to see some of this on the test. All right, at this point, this is not an all-encompassing review. I would make sure you